So for everybody who's interested in security and compliance and just love everything to do with governance and all these wonderful words that is kind of like, that thing out of Austin Powers where Dr. Evil is like talking to his son and says, I've got a whole big bag full of no right here. Or sort of a joke that a friend of mine in the public service said, what do we want? Incremental change. When do we want it? In due course. And being in Canberra, I kind of thought I'd sort of get that joke in. But there is a fair bit of that. And the interesting thing is the OpenStack has hit the point where it's no longer a science experiment, right? Where it's come out of the place where people are running it on their laptops, they're running the skunk work groups, where there's this level of enthusiasm, which people go, I could do some really cool stuff with this, to the point where it's like, well, yeah, but you're talking about running core stuff on this, that if it goes wrong, somebody's going to get into trouble, and the chances are that somebody's likely to be me because I carry words like compliance officer or risk, or I just care about this stuff. So if we take a look at some statistics, and it's a well-known fact that 36.8% of all statistics are made up on the spot. Here are my statistics. And these come out of the OpenStack user survey from April 2016. So this is relatively recent and relatively credible. The thing that I find interesting is if you take a look at that number one priority, that's the dark blue line, the thing that everybody really wants, their number one priority is, I want to save some serious money here. And if we're all honest with ourselves, a lot of the reasons why, after we get out of enthusiasts, why is it that IT management start looking at OpenStack seriously, is because they've taken a look at the price of vCloud Director and their recent ELA license, and they go, oh my God, must there be something? Is there an alternative out there? And OpenStack is certainly a viable alternative. All the way at the top, we're just standardising the same platform with open APIs that power a global network of public and private clouds. That's my sort of magic fairy and pixie dust vision of the future, right? And everybody wants that. It's somewhere on their priority list. 97% of people want that in some respect. And way down at the bottom is this achieve security and privacy goals with control of platform. Now, the interesting thing is that it's actually there. People believe that OpenStack can actually help them achieve that. But it's not the thing that they look to it and think of naturally. It's really magic fairy dust, magic cloud, saving lots and lots of money, and kind of security would be nice to have as well. So, but if we think about what stops us going to the magic fairy dust world, to the cloud nirvana, we did a survey of what's the most important stuff to people, and we constantly do these surveys, and the biggest reason why don't we go to cloud, right? And I could spend the next half an hour enumerating just security and compliance concerns, right? Just the next half an hour just enumerating those, which would be kind of cool in some ways, but not really. Really, it comes down to about 50 to 60% of the reason why people don't move to cloud is because, and it gets lumbled under security, they're afraid, right? What happens if it goes tits up? What happens if it gets hacked into? What happens if, right? As a CIO, securing the data, right? The next thing is they need to make sure that if we're going to go into cloud or move into sort of some other thing, that it's actually going to save me money. These are the two primary concerns. The interesting thing is that when we move out of the IT organisation and we see what the business wants, the thing that's their top priority is timeliness of access. They want it to be fast. In fact, they don't want security getting in the way at all. There's actually a thing you can either have accessibility or security. Something which is 100% secure is 100% inaccessible and is 100% useless, right? Something which is 100% accessible probably isn't secure at all, but it's probably delivering some significant value to somebody up until a point in time it goes tits up. But they don't really care because it's all built for failure, right? Okay. There's an interesting rant by Steve Yegi about that, which is worth talking about, but I don't have the time. So NetApp IT is a big user of OpenStack. So I'm here talking on behalf of NetApp. Yes, I'm going to give you a product pitch because that's what I get paid to do. We are a for-profit company. Nonetheless, we are not only a major contributor to OpenStack, we're also a major user of OpenStack. And OpenStack was not our first attempt at developing some form of private cloud. As you can see, this has been a multi-year journey. There's some interesting points on here. You'll notice that public cloud consumption came before the shadow IT strategy. That's probably because that's the way it works everywhere. I'm not using any public cloud, so you've got Dropbox on your desktop. Well, that doesn't count, really. It doesn't. Anyway, data fabric deployment, self-service. It's not until we start getting 2015, 2016 that we've begun to actually start going through and implementing OpenStack in a fairly serious way. It was not our first attempt at doing this. But you'll notice that component automation happened well back in 2014, where we started doing things like getting software-defined networking going. We did a lot of work with Cisco around ACI. We did a lot of work around our own automation for our own data management, data storage stuff. It's worth noting that NetApp, one of our core competencies is actually building enterprise-class IT systems, right? That's what we do. We go out, we build these things, we design them, and we sell them out to the marketplace. So we don't have a problem with finding people who really understand and live in this space. That's not necessarily true for everybody. So we've taken this journey, and we've actually built 2 OpenStack private clouds. The first one is our corporate cloud, which we actually integrate up into a proper hybrid cloud environment, which includes Amazon and Azure and some other bits and pieces, which I'll show you on another slide. That hosts about 25% of our business applications, right? So it's not everything, but it's certainly a decent chunk of our overall environment. The other thing, which is the larger of the 2 environments, is our global engineering cloud. All of our development work happens in OpenStack. There's around about 6,000 virtual machines. I think we're something in the vicinity of 20,000, 30,000 cores. It's a fairly large OpenStack deployment by most people's standards. There's a number of petabytes worth of data. This is completely walled off from the outside world. This is our core IP, right? This, that we refer to as Eng-Dome, right? There is a large sort of invisible barrier which surrounds it, which you can only get stuff into and out of it using airlock. And we actually have, the way you get into this is through a remote desktop connection, which we do actually using some products from VMware. But we have these 2 large OpenStack things. The one on the left-hand side is pretty much only KVM. One on the right is kind of a mixture of the 2. The interesting thing is that as we have evolved into this architecture, the way that we reduced the risk was that we didn't go through and do a massive Big Bang approach. Right? We actually took a lot of the learnings that we had previously through our, the work that we've done, the standardising the components, the automation of various components, and so on and so forth. And so we have this cloud management platform. It's kind of this blue box there. It's not one product. This includes things like ServiceNow. It includes things like the APIC controller, Cisco's UCS Cloud Director, some other bits and pieces. This is something which we have pulled together over time from a variety of products. OpenStack is integrated into that. But you'll also notice we have things like F5, we have VMware vSphere, we have some stuff from Palo Alto Networks, right? We did not throw out the baby with the bathwater when we went through and implemented our OpenStack implementation. OpenStack forms a part of the overall data center ecosystem here, okay? I actually have a really cool little slide, which I don't have on here, which actually shows the workflow and all the firewall rules and all the data at rest stuff. We specialize, we know that our specialty is in securing data at rest. Right? We rely upon our partnerships with people like Cisco to, and in their case, we're using their ACI technology, which also works in things like F5 and the Palo Alto Networks things to help us automate the software-defined networking portion of this so that we have a single way of making sure that stuff is secure across not just the OpenStack portion of the infrastructure, but across the bare metal portions of the infrastructure and the other parts which we have not yet moved to OpenStack. The intent within our IT organisation is to move everything within OpenStack over time. But again, that's not a religious argument, that's one of pragmatism, and it is moved on a very pragmatic basis. Okay? It uses the kinds of operational maturity that we have developed and the kind of operational sensibilities that we've developed over the last 10, 20 years. Right? This runs our core business. The other thing we've also done is we've built this on FlexPod. FlexPod is an integrated infrastructure stack that uses our shared networking infrastructure from NetApp. It uses Cisco UCS servers and also uses Cisco networking. That's part of a validated reference architecture which we provide out to the marketplace, which you effectively use to do a architecture by exception. So you take this and then you change the bits and pieces to allow this to work inside your environment. Providing you don't change certain core components of this, it's an extremely manageable solution and allows us to have a one-throat-to-choke support model. And again, this is taking relatively familiar traditional IT infrastructures and disciplines and allowing us to bring this into OpenStack. You'll notice under the roadmap modules, Some things we have there that we haven't implemented yet is Manila. We actually created Manila. This is a way of going through and having file services as a first-class citizen within an OpenStack deployment. So most of you have file shares. Wouldn't it be nice to actually have those provisioned out as file shares rather than trying to run up Windows file servers across a whole bunch of little, sort of virtual machines? Neutron, again, part of the reason why that's on the roadmap still is the fact that most of our stuff was originally done with ACI, so we're not trying to duplicate that effort at the moment. We'll roll this stuff up under Neutron as time goes by. Again, an incremental approach, reducing the risks, allowing us to become comfortable with what we're doing. And Heat, which is, of course, the final orchestration piece, that's not as necessary for us because, again, we've already done a stack of development work up here inside that cloud management platform, which is a collection of things. Heat will become part of that over time, but there are things that don't happen in Heat yet, such as quality of service, that make it unsuitable for us at this point in time. So we go through and we want to use Heat, so we actively participate inside the OpenStack user forums because we depend upon OpenStack for our own production infrastructure. So what were the results of us doing this? We saved lots of money and lots of time. The proof is definitely in the pudding. This is the reason why we have such a commitment to OpenStack, is because it is delivering the results. Remember that big bar? We want to save lots of money. It's very hard to talk about compliance without talking about budget compliance as well. Okay? It's not just about security, making sure that people don't come in. Compliance and security is a whole stack of different things. Right? So we certainly did that. We also met a bunch of other SLAs that we had agreed to meet to. And that was the other thing, reporting back to the business, is that we agreed to meet certain service level agreements in return for getting the budget we needed to implement this stuff. Having that level of measurability, the logging, the confidence in the system that allows us to go back and report back up. We don't do internal charge back, but we certainly do show back to prove that what we're doing is better than the alternatives. And we have lots of alternatives. Because that infrastructure is actually part of a larger infrastructure where we take that same data set, all the virtual machines that we have are stateless. We take all the state which would normally be sitting inside of a virtual machine, and we put this onto our storage and data management system, so we can then take that state and make that available to other cloud infrastructures such as Amazon and Azure. That we park those physical arrays right next to those things using Direct Connect, and if we need to, we can move workloads between our private cloud and our virtual between our private cloud running on OpenStack and move these things up into Amazon and or Azure. Right? In some cases, we're actually running versions of OpenStack inside of those cloud platforms as well. It's a very agile infrastructure, and again, we have the choice of where we move that infrastructure and that compute based upon cost, price, time, data life cycles, application life cycles, and that gives us a lot of flexibility. Full control over our corporate data at all times. We maintain data privacy and compliance because we are always in custody of our own data. If the data is always on stuff that you own, it's very hard for anybody, including the FBI, to come in and say, I can subpoena that data and you can't do anything about it because it's not actually on your stuff. They actually have to come through and go through our legal channels to get access to any of the stuff which is sitting on our storage. And that helps us and a number of our clients to comply with a whole stack of legislation that would otherwise be very difficult to do. In fact, some of this stuff is actually done in Europe, where we need to keep that stuff sitting inside of specific jurisdictional locations. So we actually use this stuff. We're just showing the US portion of this on this particular slide. There's no vendor lock-ins, well, except to ourselves, but we don't mind being locked into ourselves. There's always going to be some level of lock-in somewhere, right? I call it the conservation of lock-in. The thing you don't want to do is to be locked into an area which is changing very rapidly. To my way of thinking, data storage and data management is pretty mature. There's not a lot of changes happening there at this particular point in time. Cloud, DevOps, and all the rest of that stuff is changing very rapidly. You don't want to get too caught up with one particular implementation or one particular vendor at that point in time. We've got rich enterprise features, standardization across all clouds. We have complete data management, and again, data is probably the most important thing. Remember, it's a data center, not a network center, not a storage center, not a compute center. It's a data center where you collect and protect and manage your data and turn that into a valuable customer benefit or a business insight or a better business decision. That's why we have data centers. Okay. And of course, it lowers our TCO. So this is part of how we go through. And again, this technology, which we refer to as data fabric, is now the core part of what we do in the marketplace. So, that's still coming up. But all of this, right? And if I show this stuff to a cloud architect or the guys who started with the Skunkworks projects, you can kind of watch them cringe a little, right? You're talking about using shared storage. It's enterprise stuff. It's proprietary. It's shared storage. It's pets and not cattle. It's right. And part of the reason why is this, right? When we go through and you start doing this kind of planning, it's the old style waterfall stuff where we go through and we try to mitigate our risk by planning our way out of it up front. That's how we've done it for the last 20, 30 years. That's how my dad did it. Well, no, he didn't. He was a scientist. But anyway, this is the kinds of stuff, right? And it drives people insane, right? It requires you to mitigate your risk and buy stuff 3 years in advance, not having any idea what's going to happen 3 years in advance. So you, of course, buy 4 times as much, or you take your budget, you try to shove as much stuff into that budget as you can and desperately hope that it was right. And sometimes that works out okay, and sometimes it just sucks. And you end up with some poor tiny little array trying to handle 6 times as much workload as it was ever designed to do, and everybody hates you, okay? This is how the guys want to do it today. This is a much better way of doing things. Don't worry about this level of design and detail because it doesn't actually help you. Waterfall methodologies are fantastic to mitigate risk when you have a known problem, when you understand exactly what you've already done. Agile approaches, on the other hand, which involve taking lots of small risks over time, testing, cycling, lots of feedback, plan, do, check, act. It's like good old Six Sigma. But rather than spending 6 months planning, you spend 6 minutes planning. Well, hopefully a little longer than that. But the whole idea is that you don't spend a lot of time on those previous decisions. And you need the right technology to underpin that kind of decision making. If you haven't seen it, there's a fantastic book called Consumption Economics, which explains this move very, very well. Okay? It was actually written for IT vendors, right? About how we needed to change to this new world. Because in the old days, we'd sell you $1 million worth of stuff, we'd go out, we'd pop the champagne, and you guys be sitting back there going, fuck, I hope this works, right? That's not good enough, right? What we need to do is to allow you guys to take risks that are bite-sized chunks that you can take, and if it's wrong, it's not such a big deal, right? Scale out is the way in which you do this, right? Scale out, shared nothing infrastructures are the way we do this. So, hardware, capacity, software, buy it in any ways that you like, right? And as you go through, add our little bits and pieces, and if you need a bit more, you can sort of add bits and pieces as you go, scaling up incrementally. You can prove efficiency with non-destructive reallocation of resources. So you know what? If you added something in, it turns out you don't need that, take it out again. Put it somewhere else where it is needed, right? You can't do that with traditional kinds of technology. You can do this with cloud-based thinking, with scale-out technology, with non-shared infrastructures, where most of your stuff is cattle, not pets. We give you guaranteed compatibility. That means that you need to make sure that whatever you're going to be dropping in suddenly isn't going to sit there and go, oh no, you can't do that with that anymore, right? I don't know, I used to be in a purchasing and procurement thing for a bank for a while, and just trying to source a PC build that would be stable for 3 years, because that's how long it took to certify something, was just a nightmare. You need to make sure that the stuff which is coming in, right, addresses those concerns of standardization and compatibility. You need that kind of forward planning. Somebody needs to help you take that risk, right? And that's where vendors like NetApp come in, right? So the idea is to future-proof, in this particular case, your storage investment. Buy something now, buy it in a small increment, expand it, grow it, reallocate it as necessary. The other thing that we need is we need to make sure that we guarantee our service level agreements. When we go through and make a promise about how something is going to behave, we need to make sure that it will actually behave like that. Now, again, in the past, the way we did this was by buying way more stuff than we needed and hoping that nobody would ever hit the top of it. Right? That doesn't work in the cloud world so well, because what happens is the easier you make something to consume, which is the whole point to cloud, the quicker people will consume it, and suddenly we start hitting our headroom really, really quickly. There's also the fact that we have much more shared infrastructure, right? How we actually start squeezing all that that stuff out of there. So we need to make sure we have ways of making sure we put in decent quality of service that can be policy-based, right? You don't want to have people micromanaging this stuff. You need to sit there and say, this is the policy, right? If there's this wonderful thing called promise theory, which I wish I had more time to talk about, but this idea where you go through and you say, go through, do this, enforce it, and if it starts going outside of the bounds or I start getting warnings, then let me know and I can go and take some action. If you can align your purchasing strategy with that, then you can go through and say, cool, I can now go through, grab another node, add in the capacity, and I'm away and running, right? I'm not purchasing every 3 years. I'm purchasing just in time as I need it. That drops a massive amount of cost out of your system. And we can go through and just change these things via software. Again, software-defined service levels, managed via policy, controlled via things like heat, celiometer, those sorts of things. Right? And we go through and we eliminate noisy neighbours, which in a multi-tenanted environment like OpenStack is a really hard problem to solve. And if you don't think that's a really hard problem to solve in storage, please come and talk to me. I'll talk to you for like 2.5 hours about quality of service implementation on storage where you have multiple varying latencies and workloads and shit like that. It is very hard to do well. And you need to make sure that whatever you do is done repeatably. That once you... Because what works in IT without testing? Nothing. Nothing works in IT without testing. Until you've done it over and over and over again, you don't know that it's going to work. That's the reason why we do all that waterfall planning. Not that it actually works, it just makes us feel comfortable that at least we tried. Okay? This idea about proven repeatability, which is the entire essence of automation, is the thing which allows us to reduce the vast majority of risk and compliance problems inside of our environments. Doing the same thing over and over and over again with repeatability, industrial scale, is the ultimate key to us doing this. And of course, there's some technology pieces which allow us to do this sort of stuff. I'll kind of run through this quickly because I've only got 5 minutes to go and I still have more ranting to do. But you know, this is the technology underpinnings which allow us to do things like remove nodes, upgrade things, make this thing completely non-disruptive, and make it so the users never ever notice. Remember, in a lot of DevOps kinds of things, you're actually rolling stuff out in production. You do your test and dev in production. You roll up another thing. If it doesn't work, kill it and go back to the old ones. People are using half the old version, half the new version. Who cares? It's all under the REST API. Right? Continuous changes. Right? And we've proven that this works. In a lot of cases, what we do is we take this SolidFire infrastructure that we have developed. Well, actually, it's SolidFire developed. NetApp bought it because we thought it was really cool. We like the company so much that we bought it. And people like eBay, PayPal, right? PayPal is probably one of the biggest targets in the world, both from compliance, hacking, security, all the rest of this stuff. They run their entire infrastructure, their block storage sitting on the SolidFire stuff, right? We've done this in a number of different places. FICO, they do all the credit reporting. Lithium and Tableau, both cloud providers. Covardis, cloud provider. People do this stuff and they depend upon their entire business for this to be working. Which is part of the reason why, brag slide, we're probably the number one, in fact we are the number one provider of OpenStack storage, right? This is based upon, again, the same thing that was done previously. In fact, we're number one just by what people say, and we've got a reasonable amount of the NFS and LVM stuff as well. Ceph is by far and away the largest thing. The reason for that is that Ceph is what anybody starts with. If you're going to start and run OpenStack on your laptop, you're going to be using Ceph, right? It's just built into the Linux kernel. So that just gives pretty much every developer in the world. Ceph is fantastic if you run it at small scale when you're in development. If you run it at a scale where you can actually put some resources which are dedicated to it, like a couple of petabytes, 3 or 4 petabytes of Ceph, works brilliantly. It's that middle piece where there's 200 terabytes, you try to get somebody to manage it part-time, that's where people tend to run into trouble with it, right? And that's not to say that Ceph is bad. Ceph is awesome, but you use it in conjunction and, you know, with the thing. This is not a matter of, you know, magic fairy dust, everything just works, right? We go through a lot of engineering work to make sure that you can just assume that SolidFire will just work. And if it doesn't, you can call us and we will fix it. And we make sure there's all those security and governance features built in, right? Physical security, logical security, compliance and monitoring, budget conformance, investment protection, all these things factor into this. But in the end, the question you need to ask yourself isn't, should I implement SolidFire, should I implement NetApp, should I implement a traditional thing using HP Helium or a NetApp, NetApp FlexPod or something like that. The question you should be asking yourself is, organisationally and culturally, where am I right now? Because all that stuff I talked about reducing your risk by incremental changes and using an agile approach, that works really well when your budget planning works that same way, and you don't have to have a 3-year planning cycle for everything. It works when culturally you're aligned to doing things that way. If you try to put a waterfall approach upon a team which is agile and its very ways and means of thinking, you will fail. If you try to put an agile approach into a group of people who think of things in very waterfall kinds of approaches and traditional IT and risk mitigation up front, you will fail. The trick is to actually try and bring these two groups together over time, right? And you can choose both. You don't have to choose one or the other, but you need to start with where you are right now from an organisational and cultural point of view, because culture trumps strategy every time. You need to choose the technology stacks that support where you are culturally right now. So that's my pitch. That's how to do it in 30 minutes, magic fairy dust included, right? If you are interested in more information about how we go through and do this, because again, we are very invested in helping people produce enterprise-class OpenStack clouds that meet the same kinds of compliance, security, and all the rest of that stuff that we need, that eBay needs, that Nike needs, that Disney needs. I don't know if I should have just said them. Anyway, a whole bunch of very important customers who rely upon OpenStack. Go through, check out netapp.io, okay? This is where our developers hang out. This is where a lot of our value propositions are. We talk a lot about Docker, DevOps, OpenStack, and this is where perhaps the most interesting stuff is. Of course, you can go to our corporate pages too, but for my money, this is the place to go. If you have any other questions, please come and talk to me. I'm out in the stand, or ask anybody sitting here inside of NetApp. Thank you very much.